Hello, my name is Gustavo Montemayor, and this is a presentation for Ms. Rukmani Kupaswamy, Biology 1408 at Laredo Community College. My presentation is on algae and its viability as an alternative to fossil fuels. We already know it can be produced as a biofuel, but how viable is it to be used nationwide, as most of us would hope or would like to have it be used to help the environment. Now first we must know, what is algae? Most of us think as algae being a plant that grows in water, but in reality algae is not a plant because it doesn't have root-like structures that go into the ground, which defines a plant. It does grow in water, but not just in water, so not just salt water, but also fresh water. And algae is also found in some foods you eat, or you may have eaten. If you eat sushi, you may have found if you were not aware of that before, the black wrapping in your sushi, sometimes kind of like black, greenish, that's algae. That's algae, and it has if you smell it or when you taste it, it has like a saltwater or marine taste, a fishy smell. That's algae. So that's algae. So you're eating algae. So algae is good for you can eat it. It's good. And it's the basis of many food chains in the ocean and freshwater. So where there's algae, there's fish, and there's other life forms that require algae to survive and live underwater. So it's important. Algae is very important, just in that. Now, currently, according to scientific research, algae is responsible for producing more than 70% of the Earth's oxygen. That's very significant. 70% of the air you breathe is produced by algae, according to scientists. Some believe it's up to 80%. Now, oxygen is important, required for our life to live. Many organisms require oxygen. Oxygen and water, basis of survivability of many organisms on Earth. And it also helps remove large amounts of carbon dioxide from the atmosphere. Carbon dioxide is obviously the pollution, the end product of burning like fossil fuels, gasoline, the air you breathe. These carbon dioxide, algae helps remove it, keeping the air clean. And now it has also been able to generate biofuel. Very important. Algae has many significant uses to the sustainability of life on Earth. So we keep going into algae. Now, other alternative sources of energy that are currently out there that I'm sure many of you are aware of is wind energy, the wind farms, which sometimes power your house. If you have renewable energy in your home that you choose to have it, you pay a little bit more, like a cent or two more per kilowatt, and you have renewable energy usually coming from wind farms. There's hydraulic, there's solar. Solar's been around for a long time. The solar panels, I'm sure you're aware of. There's currently now new technology. There's solar-powered washer and dryer, solar-powered water heaters, solar-powered air conditioning units, reducing your electric bill, and helping the environment. There's corn, one that came out a few years back, which produces ethanol, which most of us have used because most states require a certain percentage of your gasoline to have ethanol in it, up to 10% sometimes. And water, hydro's been around for centuries. Water runs, turn to watermill, and produce some energy. We can transform it and use it for something else. And now algae. Now the question: why algae? Why not tomatoes, or why not grass, or something else you can think of? Why not something else that grows? Well, because algae has a very high oil yield compared to other sources of biofuel. And another thing with algae is that it reproduces very fast in comparison to, like, for example, corn, which produces ethanol, which takes a couple months or a few months to grow. Algae, within a matter of days, can be grown and begin to be processed to be transformed into biofuel. So it's turnaround is very quick, which is good. Now, when you go over the impacts of algae as a biofuel, the impacts of large-scale production of algae on the environment, which is the point. First of all, algae is water. This is my son, so just so you know, this is what it's like going to school online. Anyways, algae is water intensive, so it requires fresh water or water. Whether it doesn't have to be clean water, but it requires water nonetheless. And we're consumers of water. We need water for our life and our sustainability, and many other organisms require water. So how much water are we willing to sacrifice to have a biofuel? I don't know. How much? Where's the limit? What's the balance? The impact on the ecosystem. When you throw in algae into an area autotrophically, which is grown naturally, how are you going to impact that life system that's there? The animals, the human life there, the fish, the birds, the ducks, snakes, alligators, termites, everything that goes, all the rodents, the species that live there, how's that growth going to affect it? And the waste accumulation of algae production downstream and affecting wastewater treatment facilities. And another thing with algae is that pound for pound it produces less energy than regular gasoline. For example, gasoline produces, if a car gives you 20 miles per gallon on gasoline, on ethanol it's going to give you 17, for example, 17 miles per gallon. Algae is the same thing, give you about the same amount, give you less, and then it's not as effective, and it doesn't store the same amount of energy as regular gasoline. Now, positive impacts, algae can grow almost anywhere, not just out in seawater. And it produces faster than the biofuels, as I mentioned earlier, so that would quick turnaround, which would help produce large amounts of it. And it would help, obviously, the environment, reduce the carbon footprint, and so on and so forth, and make it cleaner, better earth or environment than, the way we're headed. So it would be good for everybody, for generations to come. Now, one of the major obstacles to production of algae on a large scale is the space required to grow it. The autotrophic method requires 24 square kilometers to produce 12 million gallons of biofuel. That's the natural method, the one that would just kind of let it grow on its own. Heterotrophic method, which would involve the insertion of chemicals and so on to speed up the process, requires 6 square kilometers to produce the same amount, 12 million gallons of biofuel. The good thing is that 1 kilogram of algae produces almost 1 kilogram of biofuel. That's good. So wait for the same thing. So the thing is that the heterotrophic method requires much less space, is very expensive. So would you want to pay at the pump that extra amount? I don't know, how much more would it be? But if a gallon's running at $4 a gallon, $3.50, willing to pay $6 a gallon, $7 a gallon, like they do in Europe, they pay up to $10 a gallon for fuel. So, and then you're going to get less mileage, per gallon. I don't know. Would you want to? I don't know. It's up to the consumer. And here it illustrates the amount of space required. Here's the state of New Mexico, and the square in green represents the autotrophic method. So it requires a little bit over half the state of New Mexico to grow the 12 million gallons a year. And the red square is the heterotrophic method, which requires much less space, but it's very expensive to produce. Now let's put that 1 billion into perspective. You're thinking, well, 1 billion is a lot of fuel. As I thought, man, 1 billion gallons of fuel, we could power the earth, power everybody, for a whole year easily. We'll be overflowing with algae, but apparently not. Just in the United States alone, fuel consumption is 142 billion gallons a year. That equals about 360 million gallons per day. So that means the 1 billion gallons of algae biofuel produced in a year would be burned in less than 3 days just here in the United States by being used in the United States. So that's that's pretty significant that we'll burn through 1 year productions of algae, in 3 days, of biofuel in 3 days here in the United States alone. And it would account for much less than 1% of the current use of fuel in the United States. So positive impact on the environment. When it's required, you're going to use for less than 1% of the fuel consumption. Not much. I think it has to be, and we'll go over that right now. So I think it seems like a lot, but it's not that much to what we use currently. Or that was the figures as of 2006 by research conducted. So I think algae is a viable biofuel, but not in large scale as we would like for it to be or hope for it to be to obviously help the environment. I think in conjunction with the other alternative sources of energy such as wind, solar, ethanol, natural gas, hydraulic, hydro, all these other clean energies, thinking and using them together, we can have a positive impact. But just alone, no, I think it's not viable. Just on itself, self-standing, it's not going to happen unless they come up with some awesome, which you'd be surprised, amazing scientists out there come up with something really good to make it cost effective and efficient, and be able to put it out there to the pumps. And then you also have to go into, can the engine take it, and modify the engines if you can have 100% algae. So there's other things that have to be looked at, other effects, but as a whole, just on its own, I don't think so, based on the information. But I think it should continue to be studied, and hopefully over time, as we would all like, hopefully, it could replace fossil fuels. But that's still a ways down the road. But in conjunction, yes. So thank you very much. This is my presentation on algae as a biofuel. Thank you.